Today we are learning about XQuery XML Query language. What is XQuery XML language? It is designed to be a small, easily implemented language. It's flexible enough to query a broad spectrum of information for XML, including databases and documents. It is a strongly typed and functional language. The expression is the basic building blocks. It has a human-readable syntax. Query language that uses the structure of XML intelligently can express queries across all these kinds of data, whether physically stored in XML or viewed as XML via malware. Now let's look at the history of XQuery XML. It is based on the existing XPath query language. It was designed by W3C, which is World Wide Web Consortium Working Group. The group saw a need for a language that was flexible and would cover a broad spectrum. It would have to be able to store enormous amounts of information. However, Query is still under development with W3C and participation of all major database vendors. The first document the group ever published was called Last Call, and each time they'll update it and they'll republish another one. Overview of XQuery XML. Even though relational and XML databases are an unlikely marriage, though a necessary one, they have many similarities in many environments. The main difference is a relational database are stored in two-dimensional tables, whereas XML are stored in a tree structure. The significance of the tree is the order. It is easier to shuffle information in a tree instead of a table. Most web pages are stored in a relational database. Therefore, the XML approximately converts the information into a hierarchy. The two-dimensional tables would be too confusing for users, and we'll see some of these examples as we go along in our slides. The expressions are evaluated in a statistic or dynamic. During the parsing of the statistic context or expression, the system is removing all the white spaces. It is also binding and predefining namespaces and preparing it to be used in the prologue. We'll get into more of that later also. At this point, the namespaces declared in the prologue can be overwritten with the XML namespaces. All the namespaces binding is resolved in the statistic context initialization. When a query encounters an XML variable or column, it is imported into the statistic context. Let's look at the example of the flower expression. The expression is the workhorse of XQuery XML language. It can be used anywhere in the query that is allowed, which makes it flexible. It is a basic structure for many of the queries. Unlike the XPath expression, Flower allows a user to manipulate, transform, and sort the results. It is useful for computing joins between two documents or more. This also makes the result intermediate. This is why the flower expression is such an important part of XQuery. Now, let's look at this example and break it down. The following example of a flower expression includes all the possible clauses. The flower expression itself is divided up into 5 clauses, and we will look at them a little bit later. But now let's go through this code. The for clause iterates over all the departments in an input document, binding the variable $D to each department number in turn. For each binding of $D, the let clause binds variable $E to all the employees in this given department. Select from another input document. The result of the for and let clauses is a tupelo string in which each tupelo contains a pair of bindings for $D and $E. $D is bound to a department number, and $E is bound to a set of employees in that department. The where clause filters the tupelo string by keeping only those binding pairs that represent departments having at least 10 employees. The order by clauses orders the survival tupelos in descending order by the average salary of the employees in the department. The return clause constructs a new big department element for each surviving tupelo, containing the department number, head count, and the average salary. Now let's look at each part of the flower expression. You must have at least one for or let clause in your expression. They can be as many times as needed to perform what you need it to do as separating. The optional ones in this expression are the where clause, the order clause, which usually you only use one time. Where is used to filter items through a certain condition. This clause is only needed once in the expression. It is usually located in the middle after all the for and let clauses. The order clause, the general rule of it results in return in unsorted order. So therefore you put the order clause in to get it where you want it. If you want the result turned back to numbers, to alphabetically, or names of colors, it makes it easier for that. The return is the part of the expression that is always required because you have to have something to return all your results. It is usually the last line of the expression, and it usually has the results of the calculation that was done in the expression, the sorted that was done in the expression, or the sequence that was done. These clauses can contain nodes or atomic values. Sorry about that. Here we have an example of a tree. You can see it starts out with a parent, which would be the root, as BIB. Then it goes to 2 children. After that, it continues to more children, so then your books become parents and you have children. Then as you add them in, the different children become parents and it adds more children. This way, it is easier to store information because once you store a new node in there, the tree reconfigurates itself so that way it stays balanced at all times and will not get off kilter unless you are doing a left hanging tree or a right-handed hanging tree. Then, therefore, they're a little bit off kilter, so to speak. But as you write your code, it takes care of it so you don't have to worry about it. Here we're going to look at an example of a relational versus an XQuery XML. We talked about it a little bit earlier in the presentation. But as you can see, the relational databases is a table, which it has 3 columns and 4 rows. Then the next table has 3 columns and it has 6 rows. Therefore, then you have to code it and get it to look right. We'll see that in our next slide. Here in our next slide, we see the code that is written for the table. After it's written, after it's calculated through the compiler, this is the results that it prints out. It prints a table with 5 columns and 4 rows. And that's all it is, but you still have to set up the rows and columns and tell it which one to do. Here is the code for the Query XML. All we have to do is put the version that we're using of the code. We have to set our customer ID to what number we want it, our name, our city, and then do our projects, and then go from there. Afterwards, all we have to do is this one set of code, and it will print the results in the table like we've seen in the previous slide. Let's look at this expression a little closer. The form setup of the query expression is a prologue and a body. The prologue consists of a series of decorations, definitions, and that can include namespace, which create an environment for processing. The body is made up of expressions in a sequence designed to return the query results. For example, in a namespace decoration, a prefix is defined and associated with it therefore. In the body, the prefix is used instead of the namespace. Since a developer would bind a decoration to a default element name, this shortens the code needed to be written. The module decoration is another feature to query. This decoration is associated with a namespace, which the URI identifies a target namespace. The decoration then consists of keywords that are followed by a namespace prefix, and a string illustrates which has a valid URI. One of the query's strong points is the typecasting. The typecasting is primitive type built in, which can be cast to another primitive type. A developer can cast a decimal in an integer or a decimal to a long. In the same sense, one can cast a token to a normalized string or just a string. The only drawback is the casting to and from a list is not allowed. In conclusion, XQuery is a strong type language. With the flower expression being so powerful, it is an important part of the query. This is what sets XQuery aside from all the other XML query languages available. Another feature that makes the query language flexible is the broad spectrum it covers. XQuery has the ability to store enormous amounts of information in a document form. Even though relational and XML are unlikely marriage but necessary, this relationship makes query a high-structured and a functional language. XQuery contains new improved methods that are necessary with the demand of the web pages in current times. Even with the language still under development, the sky is the limit. And in the next slide, you'll see my references where I researched all this information. Thank you for your time.